Now we're talking about factoring using the area model or the box method. It's really my favorite way. I know it's a little bit different than some of the ways that you learn, but the cool thing about this is you don't need a different rule for every type of factoring. It's always the same. So whether or not this number is a 1, you can do this factoring the same way every single time. So that's what I love about it. Well, what is factoring? Well, remember in our last video, we took something that was 2 factors, two things like, 3x minus 1 and x plus 5 or something like that. That doesn't quite get to this one. But remember, basically what we were doing is we were just changing its form from a factored form to a non-factored form. Well, factoring takes it from this disguise back up to this one, right? So remember, these are the same function, just different clothing. Well, these are not the same function. I should probably write the right one, but I didn't factor it before I started. That's okay. So they're just the same function, just different clothing, right? And so if we see it like this with no parentheses and we want to get it factored, we can just factor it. And factoring is really, really useful because it helps us find the zeros of a polynomial. So it helps us find where it crosses the x-axis. It's really, really useful. We use it for finding x-intercepts. We use it for lots of different things. And unfortunately, this F word in math is going to follow you forever. You will use this for the rest of your math classes. We use it in calculus regularly. So factoring is a good F word in math. Okay, so let's see how to factor with the area model. So remember, in the area model, we have 2 factors that multiply together, and when we multiply them together, we get all these numbers in here. We add these numbers together and we get this. And if you remember, you would get 3x squared plus something x minus 5. That's how they always turn out. We always end up with 4 terms, right? And if you do FOIL, it's first, outside, inside, last. So we know we had these 2 terms here. And we don't know what those 2 terms are right now, but we know that when we had them here, they added together to be 14. So we have to figure out what were these 2 terms before we added them together. Well, we know when we multiply these 2 factors together, the one thing we do know is that when we multiplied the first 2 terms together, we got 3x squared, and we multiplied the last 2 terms together, we got negative 5. And we just need to figure out what those middle ones were. So this is how we figure that out. We make a little x. We know that these have to add up to positive 14x. Okay, because we know that the 2 terms that we had need to add together to end up with one term of 14. Now, the other interesting thing that we know about this is that whatever these 2 multiply together to, these 2 multiply together to as well. And that's just because of the nature of the way factors work. So we know not only does it have to add to positive 14x, but it has to multiply to the same thing as this diagonal does. And so what is that? That's negative 15x squared. So what 2 things multiply to negative 15x squared and add to 14x? Well, since it's negative, I know one of them has to be negative and one has to be positive, because to get a negative, when I multiply, one has to be negative, one has to be positive. So I think, what about negative x and positive 15x? If I take those 2 together and I multiply these 2, I am going to get negative 15x squared. If I add them together, I'm going to get 14x. This takes just a little bit of practice getting there. That's why we talk about greatest common factor and things like that. And it just helps us think about all the different factors. If you're struggling, just start listing the factors. So say 15 is 15 and 1, 3 and 5. Well, those are the only factors of 15, and then you figure out which ones work. Okay? Sometimes with some numbers we have lots of factors, like 64 has so many different factors it could be. Just start listing them and see which ones work. Okay? So we know that originally when we multiplied this, that we had 15x and negative 1x. We know those ones existed, so we can put those in here. We know this one of them was 15x and one was negative x. It doesn't matter which one you put in which box, because either way you can factor it. So you just put them each in each box. Now we have to figure out, what did we multiply by? So this is kind of this reverse engineering of figuring out what were those original factors that we multiplied by. Well, to get to 3x squared, I know that this had to be 3 times x. This had to be 3x times x, because that's the only way to get to 3x squared is 3x and x. So that had to be 3x. Oop, I put it in the wrong spot already. This one had to be 3x, right? And this one had to be x. And do you know how I knew that I had it in the wrong spot? Well, when I looked down here, I can't multiply. This can't be 3x because this could never become negative x with just a 3x there. So I realized I had it in the wrong spot. So if this is x and I need to get to negative x, what did I have to multiply by? Well, I had to multiply by negative 1, didn't I? And if this one here is 3x and I need to get to 15x, I had to multiply by a positive 5. And then I just check and make sure everything checks out. 3x times x is in fact x squared. 3x times 5 is 15x. X times negative 1 is negative x. And 5 times negative 1 is negative 5. So since they all multiply to what I need to be, and these add to here, I know that these two have to be the factors. These are the factors that I would multiply together to get that. So I can write this in factored form. 3x minus 1 and x plus 5. And so just remember that these are the same equation. They are the exact same expression, and we just changed their forms. So I can go back and forth between the two. I can factor and get here, or I can multiply and get here. And they're the exact same. If I graphed these on a graph, they would look exactly the same because they are the same expression. Okay, so whenever factoring, the first thing we do is we look for a greatest common factor. That has to be taken out first before we do any other factoring. So we always look for that GCF. Remember, greatest common factor is just a number that we can divide all of the numbers by. So I look at this, and I need to be able to divide every single term by that number. And I see that I can divide this by 6 and this by 6. The greatest common factor of 12 and 18 is 6. So I can pull a 6 out. So I'm going to have a 6, and that becomes 2x minus 3. And that's it. That's all I can pull out. That's the only thing they had in common. So now this is factored. These are the same expression, just in different forms. And what about for this one? What can I pull out of this one? Well, they all have a 7 in common, and they also have an x squared in common, because if you think about this, 14x to the 6th is 7 times 2 times x times x times x times x times x times x, right? 6 x's. And then, so we can pull 2 of those x's out, and what do we have left over inside? Well, we have 2x to the 4th minus 5x minus, what is 7x squared divided by 7x squared? It's 1, and you can't forget that 1. It doesn't just disappear, right? I have to take each of these terms and divide them by 7x squared. So when I divide this by 7x squared, I'm left with 2x to the 4th. When I divide this, I'm left with negative 5x, and when I divide this, I'm left with negative 1. And I know that it's right because I can go back and forth. If I go from here to here, then I can go from here and go back and see if it still works. So I can take 7x squared, multiply it by 2x to the 4th, and sure enough, I do get 14x to the 6th. So I can do that, and I should be able to transfer back and forth between the two. If you can't do that, it's not factored properly. If you can't multiply this out and get this, or factor this and get that, you're not factoring properly. Okay, so how do we factor quadratics? Here's the first one. We're going to use the box method to factor it. So we are going to figure out, this, remember, was x squared plus something x plus 45. We just know that's how multiplication of binomials works. We're going to end up with 4 terms. We just need to know what those two something x's were. So we can put the x squared here, and we can put the 45 here. And we know that the two numbers that are there in the middle need to add to 14x, and they need to multiply to the same thing as these two multiply to, right? These multiply to the same thing, so that would be 45x squared. So what does add to 14x multiply to 45x squared? So that I just start listing the factors of 45. 45 and 1, 9 and 5, and there we go. We already get to the right ones. So if I had 9x and 5x, those would add together to 14x and multiply to 45x. So I'm going to say, well, this one has to be, again, it doesn't matter which box I put each of them in, it just changes where my factors are, whether, if I put 5x up here, I'd have a different factor here, but instead I just have it on the side. It doesn't really matter because it's the same factor, just in a different place. So now I have to figure out what did I multiply by to get there. Well, to get x squared, I know I just have to multiply x by x. There's no other way to do that. Okay, and so if this first one is x right here, what does this have to be? Well, that has to be 9, right? Positive 9 to get 9x. And then this one has to be positive 5 to get 5x. And then I check the last box, make sure 9 times 5, sure enough, it does add to 40, or multiply to 45. So this is my original function before I added those two together. Therefore, these are my factors. So I can write x plus 9 times x plus 5. And that equals the original function, which was x squared plus 14x plus 45. They're the same exact function, just in different forms. And again, if I cannot go from here to here, if I multiply this out and it doesn't get that, then I did not factor properly, okay? You should be able to go back and forth between the two. I know I'm saying that a lot, but you'd be surprised how many times people will factor something, think that they factored it right, then I ask them if it's right, and I say, well, did you check it? And they don't realize they can check it. So I want to make sure you recognize that you can check. Okay, we're going to factor this one. The very first thing we always look for, remember when we're factoring, is a greatest common factor. And these happen to have a greatest common factor of 2. So we can pull that out and we divide every single term by 2. And now this 2 stays here. And I figure out what factors, I have to figure out what do those, how do I factor this? Now that doesn't mean that the 2 goes away. It stays there and it just multiplies by these 2. If I had taken an x out, it would also stay there. But then I just factor this to factor the whole thing all together. Okay, so I need to figure out something. Let's see. I'll fill this out. X squared and negative 20. And I know that, so that means they have to multiply to negative 20x squared. And they have to add to negative 8. So what multiplies to negative 20x squared and adds to negative 8? So I just start listing my factors of 20. 20 and 1. Nope, that's not going to work. 4 and 5. That's not going to work. 10 and 2. Ooh, if one of them is negative and one is positive, this will work, right? So if I have negative 10x and positive 2x, sure enough, I will get negative 8 and negative 8x and negative 20x squared. So that means originally one of these was negative 10x and the other was positive 2x. So then I have to figure out what my factors were. Well, that's going to be x times x. That's got to be negative 10. That's got to be positive 2. And they all multiply together. So this is x minus 10 and x plus 2 are my factors. Now remember that 2 didn't go away. So when I rewrite it, I need to make sure that I rewrite that. So I have 2 times x minus 10 times x plus 2. That equals our original function,